Hello and welcome to another video presentation by the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook and today we're going to be talking about conservation of energy, but we'll be using a demo called the Nose Basher. Now several of you might have seen this demonstration done on YouTube quite frequently, but we're going to do it again today to help illustrate the concept of conservation of energy. So when we're talking about the conservation of energy, we're really talking about the conservation of mechanical energy. We're not talking about chemical energy or elastic potential energy. That talks about, let's say, for example, rubber bands or springs. We're just going to talk about the mechanical potential energy, which is anything with dealing with translational kinetic energy, usually denoted as 1/2 the mass of that object times the velocity of that object squared, or the speed of that object squared, or gravitational potential energy, usually denoted as capital U, or PE, which is defined as the mass of the object times gravity, which is little g, which is 9.8 meters per second squared, times the height of that object above our 0 point of where the potential energy is 0. Now, one thing to remember with the solving of problems dealing with the conservation of energy, you always have to establish what is your 0 potential energy point. So with talking about this, we have the conservation of energy, which I've written up on the board, which we see here that the total energy initial has to equal the total mechanical energy final. Again, I just have mgh initial plus 1/2 of the mass of the object times the initial velocity squared has to equal mg, the height final, denoted as subscript f, plus 1/2 mv final squared, which is again denoted as a subscript f. Now, some textbooks, they'll interchange whether or not the initial condition is either a 0 or a lowercase I, just to help in that establish this is the initial case, this is the initial starting point. But most textbooks usually denote the final case with a subscript of F. So what we're going to look at today is the conversion between only potential energy into kinetic energy and only potential energy again. If you've watched a couple of other video demonstrations, we've already discussed this a little bit. But now let's look about it similar to, let's say, a physical pendulum. What I have right here, with the help of my buddy Taz, the bowling ball, is we have just a giant pulley. And what this, not a giant pulley, I'm sorry, a giant pendulum. And what we're going to do is we're going to put this object and we're going to note where are its energy points. So if you notice here, it's going back and forth this way, to where I first released it, all it had was potential energy if the point at which it is directly underneath the fulcrum has 0 potential energy. So if I was to raise it and hold on to it, the moment I let go, it only has potential energy. And that value is going to be mgh, which we could find a couple of different ways. Well, then as I let go, this pendulum or this bowling ball is going to swing down, and when it gets down to its lowest point, or right directly below the pivot point, it's only going to have kinetic energy. That will be denoted as 1/2 mv final squared. Well, that's if we're only looking at half of complete arc. Well, now if we continue going, the highest potential that this bowling ball can get is going to be the exact same height it was initially. However, this case is not going to be a perfectly conserved system, because you will notice that as it goes through one arc, when it comes back, it's not going to hit the same height. That is due to loss because of friction with the actual metal chain that we're using and the fulcrum point that we're using. Now, if I wanted to calculate what is the height above here, we can use trigonometry, or we can just measure the angle. That would tell us the height above which we are. So if we knew the angle, I could then tell what is the height difference, saying that my height is really just going to be a combination of just the length of this chain and a trig function of the angle. But now what we're going to do is we're going to trust in physics. And what I'm going to do is I'm going to step to the side. I'm going to have this bowling ball placed right here at my chest, and I'm not going to move. I'm going to let go, and I'm going to trust it also doesn't hit the wall, and I'm going to hopefully not get hit by it. And if I did, it was just a nice little tap. But as you see, as I stand here, it's getting slower and slower. It's not getting to me as high. But you'll also notice, possibly, you might not be able to see it there, but this also is oscillating in a circle a little bit. That's just because of the nature of our pendulum and the nature of our fulcrum. Well, that is all I have for this video presentation for today. Thank you for attending and have a wonderful day.